Welcome to this session. Today, in this session, I am going to discuss the term called moment of inertia. First of all, what is moment of inertia? What is its importance? This thing is very important. What is moment of inertia? So I will say the moment of inertia is represented by the letter I. Okay, it is represented by the letter I. Then, what is the unit? The unit is measured in terms of meter power 4 or millimeter power 4 or centimeter power 4. Okay, both are mutually convertible. By definition, on physics, how can we fail the moment of inertia? Moment of inertia is nothing but how difficult a body is to be rotated. Okay, otherwise it is nothing but given the resistance for a body to have the angular momentum. Okay, or angular velocity. Okay, so it is giving the resistance for a body to rotate. Okay, if the value of moment of inertia is higher, there much difficulty we are having to rotate a body. That is the moment of inertia. Okay. And how can we find the values for moment of inertia? Whether it is depending on which parameter. Is it depends on material? Let's see. Okay. Otherwise, is there depending on any other parameters or properties like temperature, pressure, or any other energy? Does it have the relation between moment of inertia with respect to other properties? Definitely not. Definitely, it does not depend on those kind of properties. It refers only on the cross section of the geometry. Okay, it is called sectional property. It is otherwise called sectional property. Okay, it does not depend on whether the material is steel or material is wood or material is stainless steel or bronze. So it does not depend on material also. Okay, let's come for a rectangular section. For a rectangular section, rectangular cross section. I am telling that it is rectangular cross section. Let's have a geometry like circle having so from this it is called a cylinder, but the cross section is here circle. Okay, the cross section is circle. Okay, like that. If any other object, let's have this one. Consider this is wooden material. Okay, this is a wooden material having length, breadth, okay, and thickness. By seeing this is the front view. Okay, what is the sectional view? This section, cross section is rectangle. Okay, so like this we have to have crosses. Okay, we have to have cross section. For rectangular cross section, how can we find out the moment of inertia? So let's have the base or breadth B, depth is D. Okay, so moment of inertia is I, and we have with respect to y-axis, with respect to x-axis, two different things here. So I can have with respect to x-axis, with respect to x-axis, and with respect to y-axis, y-y. For x-axis, we consider the horizontal dimension into cube of the vertical dimension divided by 2, 12. Okay, nothing but b into d cube by 12. B d cube by 12 is the moment of inertia about the x-axis. For about y-axis, same methodology only. You consider about y-axis, consider the same dimension like along the axis. So it is d into the perpendicular thing. You have to take the cube of it. So d b cube by 12. Okay, d cube by 12 is the moment of inertia for the rectangular section. Okay. Now from that you can say that what is the unit. So b into d both are having the unit of distance only, centimeter, meter, millimeter. So millimeter into millimeter cube or meter into meter cube. So meter power 4 will be the unit. Generally this is called area moment of inertia. We are considering only area, cross sectional area alone. Okay. So this is called area moment of inertia. Okay. For a circular section, for a circular section, having diameter, okay, having diameter d. The center point having diameter d. Then how can we find out the moment of inertia for circular section? Circular section IXX. Okay, to take horizontal axis, top and bottom. Okay. So here you have a curvature. So this pi will come for the circumference line. Pi d equal 4 by 64. Pi d equal 4 by 64. And I by y also equal to pi d equal 4 by 64. IXX equal to pi d equal 4 by 64. The same thing is in the y-axis. How it is possible? It is possible since it is multi-dimensional symmetrical. Okay, to take horizontally, it is also semicircle, it is also semicircle, and vertically, left and right, both are semicircle only. Okay, so diameter is the same. So we will have the same moment of inertia about y-axis and center y-axis for the circular cross section. And it does not depend on, I told you, now I just take the cross section only. I have not taken into account for whether this cross section is made of any other material or not. Does it depend on any other property like temperature, what temperature it is, what percent is maintained? So I didn't take anything else. I just take the dimension of the cross section. Okay. So this is about amount of inertia to find out for a rectangular fluid circular cross section. Okay. So we will have another video in the next session. Thank you.